Alright, let's look at the stream to do again real quick. Okay, so we are actually finally ready to do this box. What I spent the last whole stream on was kind of putting us in a position where I could do this while still being able to do these things easily and cleanly, especially these two. I didn't do much with this, but the point is now all the parsing stuff is very cleanly organized in one spot so that when I change this, these will fall into line more easily. So, the current design is basically, I'll just walk you guys through how it works. I'm going to change to, I think this will do. So the current design, it goes as follows. You're intended to first lex the data yourself, get a series of tokens for it, and then you basically, you don't make I don't have like a parse context thing. I just pass around the array of tokens and an index, like a pointer to an index variable that gets incremented all over the place, and that serves as the context, those two pieces of information. I could bundle them into a struct and pass them around as a parse context then, but that's not the way it works right now. Then what I do is I basically say, alright, we've got the tokens, and so we start doing, I'll show you the API for this, we start doing a loop over all of the, what happens here, lex, result, lex step, push array tokens. So here we lex the whole file. Where did array come from? Oh, array is the tokens. Yes, we loop over all the tokens, and that's where we start the I counter that we end up passing as a pointer everywhere. So what happens is I pass the I pointer into here, that gets incremented further, and then it gets incremented one more time here, and that's basically it. And when it reads the config line, right, that basically just means it parses until it thinks it has something useful, or until it knows that it needs to reset, and then it'll go, okay, did we find something useful or not? Then it will go, okay, if we thought we found something useful, let the user make all these calls to different variables they want to detect. And so for each line we read, we do a check and say, did this line set any of these variables? And for each variable we do the check, right? This is basically saying, we could read these calls here as, if the thing we read was this string, then update this variable. If the thing we read was this string, update this variable. So the code just looks like a very nice list of move this like parsed thing into this runtime thing, move this into this, but to actually work, what it has to do is more than that. It's not just searching through the existing things that we found and then setting it when it finds something. It's doing a loop over each, basically for each line or for each piece of data it pulls out, it then goes ahead and does all of these on that one piece of data, and then it loops and does it again and again and again. So that's not a particularly big problem because it's not like we're dealing with super large files here, and I'm not like concerned about the speed of this, but what I am concerned about is the ability to easily maintain versions where things change and get more complicated in terms of what's considered a useful line, and the line parse requirements change or these things change. I want to just have it feel much more solid to use than this. This feels a little janky, I guess. It was easy to get it up and running, but it feels a little janky, and I want to have a stronger position from which to proceed, basically. So we're going to get off of this and switch to a more full real parser. And by that, what I mean is, step one, I'm going to define a grammar that is a superset of the things that this is currently accepting, and probably not just a superset, but really just an equivalent set to it. So I'm going to go in here and I'm going to say, let's call this the 4coder config grammar txt. Alright. So at the top we have something called a config, and what does a config contain? It contains one or more, or zero or more, I guess, sort of, I guess I would call them assignments. What's an assignment? Well, an assignment is an L value, the equals token, an R value, and a semicolon. Okay, what's an L value? An L value can be one of the following things. It can be an identifier, I guess it always starts with an identifier, and then it can optionally contain a square bracket, an integer, and then a square bracket the other way, right? So it always has an identifier, and then it may have one of these things in there too. What's an R value? So an R value can be one of the following things. It can be a Boolean literal. I'll just call it a Boolean. It can be, well, okay, so it can be true or false. Well, okay. It can be a Boolean literal. It can be an integer literal. It can be a string literal. It can be a character literal. Or it can be a compound, which begins with an open brace and has, I guess we'll call it a compound body and a close brace. Alright, so what's a compound body going to look like? Well, this is where things get a little bit more interesting. What does a compound body look like right now? It's just a comma separated array, or like list of more literals, but I think what I want to be able to do is also have like optional things. So like this is the default thing, and this would basically be shorthand for 0, 1, 2, etc., right? So that you're making a set of pairs, and by default the set of pairs, if you don't put those things in there, interprets that these are sort of ascending, taking the next available integer, but that's a semantic thing that happens on the inside, so that things like this don't necessarily have to have that. But what will probably happen is that while I'm working on this, I'm going to want it to be more like, we're going to go, I don't know, so we're going to have like command build, right, equals, I'm going to have some compound, and I'm going to want to go win equals, and then a compound, and then Linux, and then Mac, right? And then in there I can do, okay, this is build, this is this code right here. I want it to, so this would be like, and maybe I don't want to have to do, I don't know. So it would be like, maybe it's like, command, out equals compilation save changes equals true. Use footer panel equals true, right? So there's the Windows one, and I don't know. I don't know if I love that. So a different thing I could do is, instead of this, I could simplify it way down and say that we're doing it like this. This saves me a lot of boilerplate characters. So now I'm basically saying that inside a compound you put an L value equals this, and so on. And that raises the question, what if I don't put that there? Can these things actually be numbers too? So it's like 0, 1, 2, 3. That raises the question, are these things that are names, I guess, yeah, that would be the idea. There's some specific order, and each name is okay. So this is the grammar I'm going to set up. So that's a compound body right there, right? And so the compound body has the following structure. Inside of a compound body, we see compound element, followed by any number of commas and more compound elements, and optionally a comma at the end. Right? And the reason that's optional is, so if I see a comma, I can then write. So this is a little bit nasty because it means I have to do this right. So how do I really want to write this thing? Compound element. If I see a comma, and then, I mean, the code isn't that hard to imagine that pulls this off, but it's technically slightly not cool. I could say that there is no optional comma at the end. That's actually an error if you do that. The reason it's slightly uncool is usually what you would do is the code you'd write would be like, alright, while we see a comma, require that we find another compound element. What we would actually have to do is here is, for as long as we see a comma, consume it, and then try and get a compound element. If we got one, go back to here. If we didn't get one, go to here. Either way, don't error. It's just a little bit unusual. It's really not that hard to implement, though. I feel like I'll do this. And then we're going to do compound element. And a compound element is going to be either on the left side, on the left side it's either an identifier or an integer, and then an equal sign, and that's optional. And you know, this has to support this as well. An identifier, no, an R value. So here's a problem. Suppose it sees an identifier. How does it know if it's seeing an R value or going down this path, right? So to make it easier to parse, I'm going to say we have to put a dot right there if it's going to be an identifier. You know what, I'll just make this more, there we go. So now the grammar actually says that there are dots here. and that's to distinguish those names there from our values. Okay. So now, yeah, that whole thing is optional, and if we see it, we expect a dot, one of those two things, and then an equal sign, and then an R value. Yeah. So then, because of that, that means that this is optional, so I could still just write this exactly the way it's written down here, right? I could still just go, okay, so actually maybe I want to do something like this, right? Maybe I want shorter names there for convenience reasons, and there we go. So that lets me set up, alright, these two things I'm going to do without putting their names on them because it's possible to deduce which one goes to which thing because of the order they're in. These ones, just because I can't remember necessarily which one comes first, save or footer, I'll use their names, but there is some default order that if I went like this, for instance, and this was the footer one, and then I said footer here, it would throw out an error. And by doing this, I'm saying don't use the default order after this point or something like this. We'll see. But yeah, so this would let me, and we're not so much creating pairs of actual values here as much as saying this is some string that we can use, and internally that's just going to get stored, or it can be an integer, and either way we're just using that to denote what thing we have here. Alright, this works. So now this down here would all count as a real actual string in this grammar, which is what I want to get done first, which is being able to parse project files. Let me check config file real quick. I'm pretty sure everything in its grammar is, so comments, we're going to want to just say that when we see comments, we'll ignore them as if they're not even tokens, right? We're going to filter out comment tokens as not really there. Is there anything in here that would be a problem? Integers. I guess another thing we would want is float. Alright. And what about theme? I'll take a look at theme 4coder. Yeah, so this too looks like it's following the same rule. Interestingly, this has this feature where these things can be set by those, and I gotta make sure that I follow a rule that those, do they need to be declaration order or not is the question, and I feel like they should be in order. The user has to sort them themselves, and it'll be an error to try to do them out of order. So yeah, what we're basically making here is an untyped data declaration, data definition format. And so like one thing you can't do right now is you can't go like foo equals oxff ococc and then put foo here, because it'll be like, I see foo but I don't recognize it. I think I'm going to just say we're going to allow that kind of thing, and what we'll do is we'll say if we we'll have a feature that's like for every name we see, L value we see, we mark it, or we create them, and then we, as we're like processing that data, we directly mark all the ones we actually care about, the ones we use directly. And as we're going, we'll also go like, okay, I use bool constant. Oh, that means I use string constant. And it doesn't matter that it's already used. If this was foo, then foo would get marked as used. At the end, we will put a warning if there are any unused values in the config file. But other than that, we'll allow it so that we can have this nice feature where our value consists of I guess it just consists of generally all L value possibilities, because I might want to also grab like square brackets out, right? So, yeah. Yep. Alright, I think I'm happy with that as our setup. So, let me now begin implementing one. Config.cpp. So the new system, I'm going to actually, hold on, I'm going to put it right here. Config.h, struct config parser. I'm now going to implement this with an actual context token. And that's going to also carry with it a file name and the data. And there we go. So, static config parser, make config parser. We're going to pass in cpp token array, string data, and file name. Array.tokens or context token equals context start, context end equals context start plus array.count, context file name equals file name, context data equals data. And there we go. Now we can make one of these things. What else am I going to want to be able to do? Well, I'm going to want to be able to recognize some of the base underlying things that I can see here. So, static bool32 config parser recognize token. So that's going to take one of these things, and I'm going to take in a CPP token type, and if context or return context token type equals type, this is going to be if context token does not, there is less than context end, less than or equal to context token, and then result equals false, result equals that. Else, if we're in this situation, we're going to say else if, and I think I can go over to my Lexer types here, CPP token end of file. Yeah, else if the type equals CPP token end of file, then result will be true. And then that's how we recognize. We can also do config parser match token, which takes the same exact parameters, and it goes if config parser recognize token context type, then context token plus equals 1, bool 32 result, return result. Alright, so that's going to be handy, and the only thing we're missing here is we're not skipping comments. So what I'm going to do is we're going to say config parser advance to next context static void config parser advance to next config parser context do context, let's take cpp token t equals context token, cpp token e equals context end, while t is less than e, for as long as t is less than e, so t plus equals 1, while t is less than e. If t type equals cpp token comment, then break t plus equals 1, there we go. Okay, so t is less than e and type token comment t plus equals 1. Yes, okay. So it'll stop at the end, and it will stop if it sees something that's not a token, and it'll be right there, and then we'll say context token equals t. Okay. So whenever we want to step forward one, we don't add one to it, we say advance to next, and that does the work of skipping the things we don't want to see. Alright. So back here on the grammar, in addition to these things, I may want to be able to pull out the values of these things. Not sure, but let's just start writing the parse for this, and then I will worry about the data extract second. So, struct config config is, let me pull the grammar up over here, and we're going to define our types here. So config, it has config assignments in it. A config assignment is a thing that has a config L value and an R value. L value has an identifier and an index, which defaults to 0. So setting 0 here would be equivalent to not putting it there at all. It's just a shorthand. That's probably the nicest way to set that up. So there's an L value. An R value can be a lot of things. So an R value can be, well, it's going to be something we need an enum for. So let's type def config R value type. Config R value L value. Boolean, integer, float, string, character, compound. Boolean, integer, float, string, character, compound. There we go. And then this has one of those config R value type, and then a union, and inside that union we can have a config L value, could also have a Boolean. We could have an integer. We can have a float. We can have a string. We can have a character, and we can have a compound. Now, what is a compound? A compound is a thing that contains some number of compound elements. Okay, what's an element? Well, an element has a left side, it's either an identifier or an integer, so we're going to call this the ultimately it's going to have a config R value. So it's going to come down here, config R value, and on the left it's going to have a config compound, we'll call it an E value. No, I don't like that. A compound layout value L. A compound layout value is something that compound layout value type. Identifier integer count type def int32t config layout value type. Why don't we just call this a config layout? Config layout type. Config layout type. Integer. Alright, so that's a good start. Okay, so that gets us quite a long way. We have the entire sort of parser output type defined. Now I'm going to actually modify this to throw in this thing here. A version specifier will look like this. It's going to say version parenthesis integer parenthesis, and that'll be it. That'll be the entirety of our versioning system, so that if the first thing we see isn't that, we can just assume version 0, and otherwise other stuff. So that way, if in the future I want to change the grammar, I can actually have separate grammars, and as long as they all start with that, everything else will follow just fine. So if I go to project.4coder, right, this would be equivalent to if I had this here, because not having it here defaults to 0, which is the one we're defining now. The version of this particular system we're defining now. And all of these, like that version, will simultaneously tell us what the grammar is and what the sort of semantics of what's expected to show up here are. So that means the version number for the config, project, and theme are not necessarily linked together directly, right? Which could be bad news, but I think that's the way it's got to be. It's the way it's gonna be. So, with that stuff figured out, let's get to actually parsing things. Config parser config. We'll take this thing, and so we have a config. Let me pull up the grammar. So that guy we have a caller for. We have oh wait, we need to actually add something now. config version number. There we go. So there's that. There's int 32 config parser. You know, I don't like where this is going. Because it won't let me do those things. Is that okay? Is that okay? Return 0. Push that integer on there. And then just copy it into there. Version number. Okay, fine. Config parser version context. Alright, back to the grammar now. So you've got that and that are done. Assignment. Static config assignment. Config parser assignment. Config L value. Config parser L value. Config parser context. R value. Config compound. Config parser compound. Config parser context. Config compound element. Config parser element. Config parser context. Okay, so there's the things we have to implement to have a parser. Now I'm going to get to giving them all bodies. Okay. Now, how do I parse a config? Well, we're going to start with, we need to get a version. Config parser version context. And then we're going to say, for as long as we do not config parser recognize token a CPP token end of file. As long as we don't find an end of file, what we're going to do is we're going to say and we're also going to put in here a require, no, we're not going to require a version, it's actually optional. That's right. So if we don't see a token, then we're going to say config assignment equals config parser assignment context, and we'll think later about how to combine those together into the config that we're going to output. For now, we're just doing the thing that parses down the control flow correctly. So, how do we parse a version? Well, to parse a version, we're actually going to want another one of these things. Recognize key, I guess, and this would be text, or recognize text. And so now the goal is, if we're in this situation where we know that the token has actual text in it because it's there, you know, not at the end or beginning or something, but it's actually in a real spot, then we're going to say, give me A equals make token, or lexeme equals context data dot string plus context token start make string context token dot size if match lexeme text result equals true. Okay. And if we want to match text, then what we do is we take in the text, we attempt to recognize it, and if we succeeded, we advance to the next thing. So now what we can do is say, alright, so we have to config parser match text stringlet makelet string version. So we need to see version there, and then we need to match token CPP token parenthesis open. Later we're going to match one of these. Then we're going to get so where things get weird, we're going to need to get if well, yeah, how exactly do I want to do this? We want to require that we recognize token CPP token integer constant, and then we're going to want to get the value from that, right? From that integer, so that we can stuff it into the thing we allocate at the end and return. While we're here, we're going to want to visit helper.c.h, I think. Yes, as it now needs the macro defined, which is, oh, whoops. Require. The require macro works as follows. You pass in a condition. If the condition fails, you then return 0. You can only use this macro in procedures that return, or whose return type can be like type matches 0 like this, but that's how I have done this, by making all of these pointers. Returning 0 always indicates failure to do the parse, and so by saying require, I'm saying either this thing succeeds or I return a failure state. Right? Now, back to writing out the skeleton of the parsing. How do I parse an assignment? I parse an assignment by going, first I require that, well, I also want to store these, so config L value, L equals config parser L value context. We'll do the same thing with an R value, and we're going to say that we require L and that we require R. We need both of them in this case. Alright, so how do we parse an L value? Well, we parse an L value by saying config L value. No. We require this right here wants to have a config parser advance to next context. We require that we match identifier, and then identifier we want to pull it out right there. Then we optionally say, alright, int32 value is 0 if we recognize that the next thing we see is a CPP token brace open. Sorry, bracket open. If the next thing we see is a bracket open, then we're going to consume that. And we're going to, well, I guess what we want to really say is if we match a bracket open, then we require that we match both a bracket close and before that CPP token integer literate constant, right? But we don't want to match that one. We want to recognize it so that we can assign value to it first and then advance, and then we'll match the closed bracket if we can. Alright, how do we parse an R value? Well, if we recognize a CPP token identifier at the beginning, coming up next in line, then what we're going to do is we're going to require that we can parse an L value. And we'll probably want to store that L value. So we'll require that we get L. Alright, if we don't find ourselves in that scenario, then we might be finding ourselves in the scenario where, and we're going to just keep on checking for which token type we recognize, where we recognize something else. So it could be that we're looking at a Boolean constant. It could be that we're looking at an integer constant. It could be that we're looking at a floating constant. It could be that we're looking at a string constant. It could be that we're looking at a character constant. Or it could be that we're looking at a brace open. And all of these, actually we're supposed to take this context thing that I forgot to pass in. There we go. There. Okay, so if we see Boolean constant, then we're going to figure out its value and then advance to next token. If we find an integer constant, we're going to find out its value and advance to next token. Here we'll find out the float's value and advance to next token. Here we'll find out the string's value and advance to next token. Here we'll find out the character's value and advance to next token. Here we're going to say, okay, advance to the next token right now, and then give us a config compound, config parser compound context, and then we also require that you match a token of the type CPP token brace close. Alright, so that lets us say we require to find a brace close right here. and then our value is actually fully parsed, and the question is, how do we parse a compound body? Well, the first thing we got to do is we are going to find a compound element. Context. Alright, so we're going to grab an element, and then what we're going to do is we're going to say, this is where we have that weird loop I was telling you guys about at the beginning, for as long as we can match a token context CPP token comma, as long as we find a comma, go ahead and try to find another element. So this, if element equals 0, this is the trouble, right? Okay, so what I really want is we're going to move this into here. So this goes down here. And we're going to say, for as long as we can match a token, or a comma, if config parser recognizes a CPP token brace close, then we're going to break. Otherwise, we require that the next thing you see is an element. Right? So this way, this is responsible for the close brace, so we can do this fairly simply. We say, yo, grab another comma. If the next thing we see is a close brace, then get out of the loop and go ahead and consume the close brace. If the next thing we see isn't a close brace, then it needs to be an element, and then consume it and come back up here. If at any point this fails, as in that we don't match a token here, then we'll come down here and find this, and so it'll be okay that we didn't match this because it doesn't actually return 0 right away, and you can come down here, and if there's a brace afterwards, it'll still accept. Okay. Okay, compound element. So to parse a compound element, we want to say, alright, if config parser matches a CPP token period dot, then we're going to at some point require that it also matches an EQ sign, and before that we're going to say if boom else, if boom else return 0, and inside there we're trying to recognize CPP token integer and CPP token identifier, and if we find either of those, then we will advance to the next token, and we'll have to do something to get them, but we'll do that later. Alright, and then after that, it then config r value, config parser, r value context, and we can require that we have an r value there. Alright, so that won't compile, but that is the basic structure of the parser done. Okay. So we're going to want to think about a couple of things. So one, these optional things here. I said I would fill in the first ones with sort of 1 or 0, 1, 2, and so on, starting at 0, right? And that means I want to ask myself, what happens when that's not there? Do I not put it into the original output and let whoever's handling this thing take care of that? Or do I want to automate the thing that fills that in if it's blank during parsing, right? Because I'm outputting some data now. I either have the option to solve that problem while I'm doing this algorithm so that the output data has that problem solved, or I output data that hasn't solved that problem yet, right? That data format has not yet done the work of being transformed to specify what and where and how the defaults are happening, and leaving it up to someone else to do that transformation. The reason I'd like to get it done during parsing is because there's a very convenient place during that for loop, right here, that I could just get it done if I pass in the default value to the parse element. So, the only thing is then I have to do some like weird passing things in and out besides just the basics. But that's not the end of the world. So I think we will do that. I think we'll have our parser determine what the default value is as it's parsing, and it's going to never mind, I take it all back. I will only admit the fact that this one was unset, and I'm going to let analysis later on do the work. And the reason, well, yeah, the reason for that is I'd like to keep this parser totally pure because it might be that different files kind of want to do different, like, interesting things there that are not as simple as just incrementing the integer. And yeah, having those be different could be confusing for users, but I think that's a design decision that I'd like to make later. You know, I don't want to be forced to decide if all of these are the same or not right now, which is what I would have to do. I would be forcing myself to decide that they're all going to be the same if I do that. By not doing it, it allows me to, in the future, just make them all the same anyway by treating them the same externally and maybe having a separate layer that does that, or allows me to make them different if I want. And it's possible that this is not the final version. It's very likely, I think, that this is not the final version of these file format parsers, so yeah. Alright, so let's go back up and start working on the next phase of this. So, in order for this to work, not only does we need all of that information, we need an arena. Because with that, what we can do is we can say, alright, these things here which are supposed to return these things, they just do that by pushing them onto the arena. So, how do I want to do that? So, like, right here, push an array onto my arena, one config. We're going to return that config at the end, and along the way we're going to assign the config right. It needs a version number, which is this version here. It needs a first, a last, and a count. And in order to get those, what we'll do is we'll have config assignment first, last, and count up here. So every time we get one of these, we're going to require that we got an assignment. And then we're going to say, okay, if first equals 0, first equals assignment, last equals assignment, count plus equals 1. Of course, that's not the whole story, because we also want to, when the assignment comes back, we want to, well, do I have ZDLL here? I feel like I actually do. ZDLL? Yeah, I have ZDLL set up already. Perfect. ZDLL stands for zero-ended doubly linked list, and that means I can just call or evoke my ZDLL pushback macro, which takes the first and the last and the new thing I'm pushing on there, and automatically does the right thing with those pointers to get assignment previous and next set correctly, and to get first and last set correctly. And then I can increment my counter by 1, and so then these can just be first, last, and count. Alright, now, yeah, we're going to go with that. Now this one gets a little trickier, because now I have a token. I'm going to say we're interested in lexemes enough, it seems, that config parser get lexeme, config parser context, string lexeme, lexeme return lexeme, config parser get lexeme context if lexeme dot string does not equal 0, and we match this. And there we go. We've got a result up here. Yep, that's so good, still good. So then what I want to do is I want to say static int32 config parser get integer config parser context. So we're going to say string config parser get lexeme from the context. We're going to take the value and we're going to say, do I have a string to, I have some kind of integer parsing out of this, right? To int, string to int. Oh, my naming scheme on this library is so bad. I gotta fix it. Alright, string to int, return value. It's gonna be so painful to go through that string library and upend it from its root, uproot it from everything and replace all of its nonsense with better things. So, that's good. Boom, boom. Alright, I want everything up to here. Hold on. Putter equals push an array onto the context arena, one int32, and then return that putter, like so. Make config parser, along with everything else, is now going to take a partition and alright, I want everything up to that one that I've implemented to be compiling, so if it's not, we have a problem. Token size. Recognize token. Recognize text. Alright, perfect. So, we grab the value, we advance to the next line, and we store that. Okay, we return the putter. Very good. Config assignment, config parser assignment. Yeah, so all we have to do here, I think, let's go over here to config. What does an assignment look like? Yeah, so an assignment just says, alright, I have one config assignment equals push an array onto the arena, one assignment, assignment L equals L, assignment R equals R. We're allowing whoever called us to fill next and previous. And then probably make sure I've set aside my OCD so I don't end up coming back later and hating that decision. Alright, there we go. Okay, so there, parser L value, recognize token. Alright, config parser, get lexeme context. So there's our identifier. Then we want to get the integer value out of that. Config parser, get integer. And then config L value equals push an array onto the context arena, config L value 1, get an L value, identifier equals identifier, L value, index equals index. I know I called it value up here, that was stupid. Index equals index. Return the L value. Alright, R value's up. Okay. So to make an R value is going to be more tricky-ish. So in this sense, in this case, the way we make an R value is we go, okay, config R value, push an array onto the context arena, one config R value, and then type equals config R value type L value, R value L value equals L, return R value. And that's the basic idea. Config parser get boolean context, get integer, get boolean, we get the lexeme, bool 32 b, I guess, value maybe, and we're going to just do if string dot size is greater than, or if match string true, right? That's how we know. All right. Actually, we don't need those values sitting around cluttering up our idea space. Get bool. Grab this shit. Boolean. Boolean equals B. Any problems? Ah, shit, this needs to be an L value pointer. Okay, so yep, this is just a simple config parser get integer, and then advance next token, and then grab this shit, and then integer, and then v on the integer. So this one, I'm going to say we're not supporting floats for now. Because, you know, just like that, kinda. Alright, so that makes my life easier. Config parser, get lexeme, context. We're gonna wanna run a string escaper, but I don't have one written yet. So s equals config parser string escape. Wait, don't I have something sitting around? Do I have something? Is it in the string library already? Escape. I do. I have a string interpret escapes. How does that work? It works for // /n /t /quote /at. Why would I need /at? Who exactly was this written for? You know, I don't exactly understand. Oh, that's a 0. I see. So /0 becomes a null. I see. I should definitely upgrade this to be a full escaper. It's going to do C-style escaping. This is like a subset of C-style escaping. We'll keep it for now. No, there is no good command for that, Philadelphia. That's a good point. In fact, my to-do list over here is actually missing some important things I'm going to do. So this one. After this, I'm actually going to do another thing that I didn't list here that I should have, that I don't know why I didn't think of it. I must have just been feeling like this list of new features was already getting long or something. But I also plan to, basically, I'm going to do the following things. All in that category. So actually I hadn't thought of yours, but so line comment, block comment converters. It's a good idea. Hadn't thought of that one, but I like it. I'm also going to do one that turn text, so it's like text into an escaped C string and text into an escaped C format string. And of course these go both directions, right? This one is not actually both bidirectional, it'd be like that, but you could make a approximate like backwards direction, so it's more like this, right? Yeah, I want to write these because I write a lot of code that ends up being like that thing I did earlier. I don't think you were here when I did this earlier. I once every day or two or three, maybe once a week or so, end up writing some code that's like, alright, we've got some code that we already have written and we want to do a bunch of variations of it. So I end up like with like fprintf, and then here's a new line, and then up to here, and I just want a thing that can be like, alright, let's take something in config.cpp, and let's say here's my example. I want to be able to just say like bang, and it's turned all of that into a string, and then I can go in there and manually split up the parts where I'm like, okay, so now the integer is the part, so it would be like it would automatically put in this, right, and it would leave it in multi-line format, right, all the way through, etc. And then I could come in and manually be like, alright, we're going to pull this out separately, and then it's like, alright, that's separated, and now I can do something with it, or I can take the integer part out and replace it with %s for a format or whatever. So if I do, like, of course, if I had code that was doing a modulo, I would want it to escape that modulo. So yeah, the plan is to make some stuff like that. Those are the ones. I hadn't thought of the comment one, but it's a good one. The other thing I have had on my mind, so I have this thing that lets you do this, right? You can just surround some code and hit Alt-I to if it out. I've been wanting to make one that does like this, and then you hit like a button that selects to here and here, right? Kind of like I do with scopes. So something that's like, I have this for Alt square bracket, right? Zoop, zoop. I want one that does that to if 0 and if, and then I want to be able to, from here, hit a single button that just toggles it, so I can just be like, oh, ding, ding, and switch these things on and off, right? Hope that makes sense. So those are some of the things I didn't list there that I plan to do that are like little convenience things that I think will help me out. And since the string escaping one and the comment block idea you propose are so similar, I might as well do them both, right? Alright, so anyway, string interpret escapes, and that just works by taking a destination pointer, I guess. So the idea is, if I do s equals substring s1 s.size minus 2, I believe that's how substring works. Can't remember because, again, horrible naming schemes. Alright, so then I'm going to interpret that, and I'm going to give it space. Guess that doesn't get returned there. So space is just going to be this thing that we push onto the context arena char size of our s there. That should be plenty of space because we're interpreting escapes back down, so the string gets smaller. So that should be more than enough space, or at least enough space, I should say. And then we escape it. I don't quite understand. How does interpret escapes? How does one find out the length of their string afterwards? I guess it's null terminated, so we add a +1 there just to be sure, and then we're going to push an alignment on after that. Please realign to 8, and then s can equal string make string slowly on that space, and then we're going to take that, and that becomes, right, we copy one of these, and it's a string, and the string is that string. Alright. Actually, why don't we just do that? There we go. Yeah, this is C++. Alright, so almost out of time, but we're also almost done. Config. This is going to be the same as this. Except I'm going to have to come down here and do a little bit of this. How do I find motivation? I don't. I mean, like, I didn't work on this at all in April, partly because I was busy, and partly because I didn't feel like it, and now I feel like it, and that's because I gave it time until my natural interest rekindled, you know? And then once I'm interested, I push it hard until I lose it again. And I don't overdo it. I don't, like, sit up all day every day until I burn myself out, but I give it a good forward momentum when I have motivation, and then if I lose interest, I wait until it comes back, and I don't force it because that seems to hurt my motivation, and that's pretty much all there is to it. If you're talking about how do I find motivation, like for work instead of for the 4coder, it's a little different, but not that different actually. Alright, there we go. And then for this one, yeah, we do that, and then for this one, we're going to do that. Compound equals the compound, return the R value. So, the basic structure is we see an identifier, we attempt to get an L value. If we see any of these things, we just take it by itself and interpret it, and if we see an open brace, we need to make sure that this is not failed to parse, and there we go. So those two do identify the first token and use that as a branch to decide where to go, and then parse more, and if we fail that parse we return 0, otherwise we return our thing. I see. So here's a couple of things that makes it easier for me. So for one thing, I started learning C++ back when I had more free time. I didn't have to like learn after work every day or something. Second, the job I have now doesn't work as hard as most jobs. Like, we don't keep a 5-day work week. We have 4-day work week, which gives me Friday off basically. So that helps, because if I had 5 days a week of work, it would take me more time to get to the point where I had motivation to work on this on the weekends and in the evenings and stuff. But as it is, I can like build up like sort of stamina and interest because I have more spare energy, right? I can do that more quickly. I can do that build up more quickly. So I mean, if that's not an option for you, then it's tough. But you know, if you just give it time, and then at some point maybe you'll find a few days where it's just like, it's not just like I want this but I am too tired, but like you really like it will be fun, so that it's not just a matter of I mean, I don't know how to say it except that if when you're trying to squeeze in side projects, you have to wait for the motivation to be so great that it's not just I wish I had time for this, but it's like this is what I will do for my entertainment right now, right? This is what I will do for fun. If it doesn't get to that point, then you're just pushing yourself to work super hard, which kind of sucks. I mean, you could try to push yourself to work super hard, but I don't do that, and I can't really give you advice on how to do that. Yeah, and that's just for this sort of side project stuff like 4coder. For work, I would do it a little differently. I do push myself, even on a slow day, I want to push myself a little bit, and that's where a lot of my energy is going, right? Since it takes energy out of you to do it when it's not fun, you can only do so much of that without burning yourself out, which is why I only do 4coder when it's fun. I don't try to push myself on this one. So, with that said, we're now building, and I don't think that means that we're done. I think I actually have to do a little bit more. Yeah, I have to do two more. Once I have these two done in a first pass, we'll call it a day. I won't test it. I'll do some more work on this on my own time, because I have to wrap this up before 6, and it's getting close to 6 now. So let's wrap these last two up. So, does not equal 0. Config parser match token compound element. Right, so what we're really doing here is we're making a new linked list. We have a first and a last and a count. At the other end, we're going to make a config compound, which we're going to push right here. Context arena, config compound 1, compound first, last, and count. Return the compound. Okay, and then we need to, anytime we get one of these, ZDLL pushback, first last element, count plus equals 1, require the element does not equal 0, ZDLL pushback, first last element, count plus equals 1. What did I get wrong here? What did I get wrong here? Whoops. So compound, yeah. This does need a next prev for it to work. Yeah, so there's some weird things that happen where you're like, why don't I want to do this thing which I enjoy today? So there's two different takes on that situation. There's like when that happens at my like for day work stuff, for day job kinds of things, and then there's when that happens for side project kinds of things. And they're probably, I mean, what's interesting is there's a little bit of a difference in where that comes from for them, and there's a difference in how I respond, and they're kind of like weirdly opposites to each other. I'm not interested in doing this thing comes up quicker for day work stuff, I find, than for side project stuff, because I choose my side project based on what I will most naturally be motivated to do, because there's literally there's no money in it, there's no motivation to it besides that I care about it. For day work stuff, the motivation comes from the fact that it's like it's a professional environment, so you got to get it done to get paid. You got to get it done to improve your skills as a professional. You got to get it done as a part of like the greater, because since it plays an important role in the greater scheme of all the things that it needs to fit into. And so for all these reasons, you have motivations besides I find it fun to do it. And for some reason, at least for me, those motivations fade more quickly. So when I start a project at work, it'll often be like, okay, this is awesome for like a month. And then after that, I'm like, oh, okay, here we go, another day of this. And I still do the day without really slowing down much, but it's like, if I could just do the thing that would make me happiest, it'd be like wave a magic wand and that thing is done and I get to work on something else, right? Like it's hard to stay motivated simply by the idea that once this thing is done, it would be awesome. I no longer care. I just wish it was done so I could do something different, and that's why I keep working on it. For personal projects, for whatever reason, although the motivation lasts longer, it's also like once the motivation is gone, if the only reason you wanted to do it was because you cared about it, once you're not having fun anymore, it's pretty much impossible to make yourself work on that thing, right? You have to wait for it to become fun again, is what I find. So doing something simply because it's fun is a great way to keep yourself motivated for a long time, but it's a poor way to keep working when you've lost the enjoyment. Finding other motivation structures seems to make it so that you don't have as much fun with it for as long, but you are able to make yourself keep working, or at least I'm able to make myself keep working without really hating it too much, right? Without it being like painful. Just kind of, I guess, boring. Right? Whereas it's like painful to work on something if the only motivation you had was because you cared and now you don't. Alright, so we have compound working. I think we have compound written in such a way that it looks like it works. And now finally we have to do element. Layout var value. Right, okay, so we need to have another option here, which is, it might be that we have unset. And so right here we're going to have a config layout, which is cleared to 0 initially. If we see this path, then it's actually a layout type of config layout type identifier, and right here it's config layout type of integer, and right here layout.identifier. We acquire that by going config parser get lexeme on the current thing. Get integer. So that creates those, and then finally we can do config compound element compound. Okay, good. Just making sure I spelled that right in both cases. Element equals push an array onto the context arena. Config compound element 1 element L equals layout, element R equals R value, return the element, and then we leave it up to whoever is calling us to figure out what to do with next and previous. Great. So now we're fully parsing and extracting all of the information out of the text format and into this newly defined config abstract syntax tree. So next time I work on this, which won't be right now, and that probably won't be on stream, but the next thing I have to do is this code down here that implements the config var stuff. That's all going to go, and it's going to get replaced by stuff that lets me query a tree and say, find in this tree a value for this variable. And I might do like an in-between stage where I have the tree, and then you could imagine just going straight to give me a value for this variable, and that creates a thing that looks up into the tree, searches down, and goes, I found the value. Here it gets set to this thing, and then if that is also an L value, it then searches that for a value, right? It searches that for what its value is until it resolves. But I could instead do another layer of processing to speed that up. So I have the tree, and then I could do a thing that descends the tree and builds a lookup table, and then instead of having to send the tree to find, alright, scan all the elements for one whose name matches me, then do whatever else, I could instead say, look up in the table, this name, is it there? Yes. What value does it have? This thing, go. Right? I could also do a thing that's like, alright, for any of those compounds, we want to be able to maybe transform that data into something else, maybe, possibly, for processing it too. We'll see. But that's all stuff I'm going to work out over the next, I don't know, we'll see if I work on 4coder between now and next 4coder Friday. But I will probably work on that over the next week. And one way or another, what will happen is, instead of doing a loop here, once we have done the lex, we'll run that parse that I just wrote, and then we will use that data to somehow do these queries in sort of very short time, maybe like one at a time. Instead of having each one repeated on a sort of m by n matrix of time spent, it'll be like time spent on this was less than linear to the size of the file, time spent on this was less than linear to the size of the file, and the whole thing adds up to about n plus m work, n for the parsing and m for all of these, kind of a deal, right? So it'll be a speed up, but even more importantly than that, it'll make it very easy for me to move this code around, because it'll be more boilerplate. The whole like grab the file, get the token space, initialize a lexer, and lex it, all that I can just turn that boilerplate into a single helper that returns to me the final process data, and then I can do whatever I want with it down here, right? That way this code and this code will be much smaller, and therefore easier to do smarter things with the actual contents of the format. After that, we can get on to actually upgrading the project code and eliminating this old parser. Anyway, don't know how much of that will be on stream next week or how much of that will be in between, but until then, I will see you next Friday. Bye-bye.